And good afternoon from Massimo Banzi. Today I am joined by Jenny Plunkett from Edge Impulse. Hi, Jenny.
Hi.
Welcome. So today we're talking about this project that we are doing with this very iconic brand called Keyway. In the background here, you can see the image we created for this live stream. So I'll just talk about it for like a minute on what we are working on and what is the objective of this project. So Keyway, let me just add an image just to give an idea. Keyway is a very iconic brand, at least in Europe. And for a lot of people like me, it's very iconic because when I was a child, this was the classic raincoat that we used to wear as a kid. You could package it up in a fanny pack and carry it around, and when it was raining, you would wear it. So a lot of people in Italy and France specifically are very, very attached to this thing, and now it's a very fashionable brand. So the idea was that we wanted to work with them to see what happened if you have sensors that are in a way embedded in a jacket, and the jacket is essentially something that you can essentially build with. And so we built some specific hardware for this based on our Nikola sense. But then as we were developing this idea, we realized that the hardware that we chose, and we're going to talk about it in a second, is capable of running machine learning algorithms, specifically tiny machine learning. So we asked Edge Impulse to sort of join this project with us, and so that we could build some kind of a competition for people who are interested in these kind of topics to see what happens if you have a jacket, if you have a piece of technology that's embedded in the jacket, and if you could use machine learning, what kind of applications can you build? So, I'm just going to show you very quickly. So Jenny is wearing this keyway. Do you have the device connected to your keyway, or oh no, you're wearing it on the?
Oh,
Okay.
yes, I don't know lanyard.
So I'll show it here as well. So we designed this device, which you can see has some kind of a metal ring around it, which basically becomes the tab that you pull to kind of operate the zipper on your jacket. And the idea is this basically integrates this object into the jacket, and you can carry it around with you because this hardware has a number of interesting features. It has a bunch of, it's based on what we call the Arduino Nikola Sense ME, and it's a piece of hardware that can detect movement, can detect the air pressure, but also has a sensor that can actually detect certain kind of gases, and it can be trained to understand the presence of certain kind of gases, which leads to a number of very interesting projects. In fact, I wanted to ask Jenny to speak for a few minutes about the project that she built with this hardware and the Edge Impulse technology. And I have the banners ready when you talk. I will write the URL at the bottom. So do you want to tell us a little bit about the experience of using this technology, the Nikola technology with the Edge Impulse tools, and what people can do with this?
Yeah, of course. Well, I'll take it back. Hi, everyone. I'm Jenny, and I'm a developer relations engineer at Edge Impulse. Just wanted to share a little bit about Edge Impulse and what we're doing to enable the intelligence on the Nikola Sense for this QA and Arduino collaboration. Our Edge Impulse is what we enabled for the Arduino machine learning tools that you can see here in our documentation. Edge Impulse is the leading development platform for designing, training, and deploying machine learning models towards the edge. And we can log into the Arduino tools by going to cloud.arduino.cc. And once you've logged in with your Arduino account, you can select the Machine Learning Tools button under Integrations, and that will launch the Arduino Machine Learning Tools powered by Edge Impulse, which you can use to design and train your machine learning model for your Nikola Sense using any of the onboard sensors. And I've just opened that already. On the Kway project page, if you go under software, we already have a project built using beer versus water. And you can find that at the bottom of the software page. And I've replicated it in the Arduino machine learning tools here on this page. And I think I've given you a link, Massimo, so you can add that there. And this project is essentially a machine learning project that allows the Nicholas Sense onboard gas sensors to detect whether the device is near gas or water. Sorry, my door, 1 second. But yeah, so this is the dashboard. And for every Edge Impulse project or our Arduino machine learning tools project, it's equivalent to one machine learning use case. And this one I'm going to show you is the beer versus water. Sorry, 1 second. There's someone at my door. Hello?
I'll take over for a second while Jenny deals with the intruder. But so yeah, oh, she's back. Let me put her back to stream.
Oh, sorry about that. I cannot control when the people from the mail come.
No, but, I know. Don't worry about it. Also, you're on a boat right now in Amsterdam. So
I'm on a boat. There's the mail. The packages are coming.
There were people on canoes outside your window.
Yeah.
So, it's a peculiar situation.
A lot going on.
I'll give you back the stage.
Yeah, thank you so much. But anyway, so we've linked to this project and we've added the link to this project here at the bottom of the screen. But this allows you to essentially ingest data directly from your Nicholas Sense into the Arduino machine learning tools, where you can then design and train your impulse or your machine learning model. And then you can deploy this model directly from the Arduino machine learning tools onto your Nicholas Sense using the Arduino library that this website creates for you. And I just wanted to quickly go through and show you how easy it is to design and train these models. If you go to data acquisition, all of this information about how to ingest new data you can find in our documentation for the Arduino Nicholas Sense. And that's also available on the software page of the project page. But if you go through, it shows you, one, how you can ingest new data and how you then deploy it. And what I did today was I used the Arduino CLI and the Arduino IDE to do this. So in this project for beer versus water, we have 3 different machine learning classes that I've collected. One for the water when the device is directly above a cup of water, one for beer, and one class for the ambient environment. And these classes are then what I'm going to use to collect data from the gas sensor on the Nicholas Sense when I'm holding it above various cups. And this same sort of technique can be applied to any type of use case that you'd like to apply for the Nicholas Sense. For example, you can use the temperature, humidity, pressure, and gas sensors all combined in a concept called sensor fusion to enable you to find more insights about your world and your environment, such as your city's air quality and more. But in this project, I'm using just the gas sensor. So I've collected about 1.5 minutes or 2 minutes of data per class for my training and my test data, which you can see in the project. And then I'm going to move on to the impulse design, where I have my time series data, which is my raw data here on the left. My white box here is where I'm going to be doing my digital signal processing. And all of this is available for free within the Arduino ML tools. So you can go ahead and log in with your Arduino account and follow along without having to write any code. You can then add your classification block, which is where we do the training of the machine learning model. And I've also, for this project, added an anomaly detection block, which will allow you to detect other types of liquids that your Nicholas Sense is by. Without having to add more machine learning classes. So based on the output of the anomaly score, then I will be able to say that, hey, this isn't beer or water or ambient, flag this as some sort of anomaly, and maybe you can refine and update your model over time using the Arduino machine learning tools. So I've created this project and I'm going to move into the DSP block. Again, these are just pre-written Python code snippets that are available for free within the Arduino machine learning tools. And the DSP code that is behind these blocks is also open source, and you can find that on the Edge Impulse GitHub page. So I'm just going to extract my most important features from my gas data that I've collected from the NICLA sense. And again, information about how I got that data off the device can be found in the documentation on edgeimpulse.com. So all I've done here is I've clicked calculate my features. I'm in the public project view, so I can't see the button right now, but it's the same exact thing. And I've also selected to calculate the feature importance, which is then what I'll input into my anomaly detection block. And this is what we call at Edge Impulse advanced anomaly detection blocks, which allow you to basically use an algorithm that we provided in the Arduino ML tools to determine what are the most important dynamic features of each signal that I've inputted from my data, which is the gas minimum, the gas root mean squared, for example, the standard deviation. What of each of these of types of data that I've imported from my DSP block are going to be the most important or most relevant for the anomaly detection block. So I'll just go into the neural network classifier block now, and this is where I will click Start Training to simply one button click Start Training my machine learning model. There will be an automatically selected neural network architecture available for you here. But if you're familiar with writing TensorFlow code, you can switch into expert mode and see the exact code that was written for this machine learning model. But because I'm not a machine learning expert, all I've done is just dragged and dropped various layers here and clicked on Start Training, and then I get this output on the right. And I see the percentage of accuracy that I have for each machine learning class from ambient, beer, water, etc. And I can also see which of my training and test samples were mispredicted to be the wrong class, or after I've trained my model, which of my samples against my validation set were identified to be the wrong class or mispredicted. And I think there's a couple comments already. The board that we're using for this project is the Arduino NICLA Sense ME. And you can find that on the Arduino website, and you can find the documentation for this board in terms of Edge Impulse on the Edge Impulse website as well. And Massimo will give you more information about where you can get the NICLA.
Yeah, I will touch upon it later. So,
okay.
And also I replied on LinkedIn because this webinar is being recorded. So if someone cannot stick around for a little bit longer, they can watch this later.
Great.
So thank you very much for this. This actually, to me, it's very important because it shows that using the Edge Impulse tools that we integrated into the Arduino cloud, it becomes incredibly simple for people to build a machine learning application in such a tiny device. And I think this is the process you showed normally would have taken a lot more work with a lot of crazy command line tools. And now it's all very visual, very well laid out, and it generates a piece of code you can put in your Arduino program and you don't have to worry about it.
Yep.
I think it's quite important. Mm-hmm. So actually, I wanted to touch upon very quickly on the hardware that we are using, because some people ask about the board. So I'm just going to share this thing. So what we are using as a basic hardware is this board called the Arduino NICLA Sense ME. The NICLA family is a family of boards that are 23 by 23 millimeters in size, so they are barely a little bit bigger than 1 inch in size for the Americans in the audience. And it's packed with a lot of cool sensors. It has this, there is a module that you can see in this picture, which is a Bluetooth module. It's a processor with Bluetooth capability the processor is from Nordic. And you can see that on this side, there's a number of sensors on this side. There's also these metal capsules that I don't think you can yes, in this part of the left side of the board, there are these metal capsules with a little hole on it. One is the gas sensor that Jenny used in her project. And the other one is essentially measuring the atmospheric pressure. But this thing is so precise that it used correctly, it can actually tell you exactly which height you are with an incredible precision. On the other side, we have, it's got a big Bosch logo because on this particular product, we used all sensors made by Bosch SensorTech, so they're very high quality sensor. We have micro USB. We have this connector, which basically allows you, the connector that you see on the left, allows you to use this device essentially as a sort of intelligent sensor for another device. So this one, for the sort of engineers in the audience, is an I2C bus. So you can connect a cable, connect it to another Arduino or another device of some sort. And then there is a connector for the battery. So the device that we basically built for this project is basically taking this board and packaging it up. Let me remove this. And packaging it up in this little thing here. At the moment, it's blinking. Oh, nice, we're doing it in parallel. It's blinking green because hopefully the air quality in this room is okay. So we program this device with a firmware that at the moment is just simply measuring the air quality, because this sensor that's on board here is able to actually measure that. And then we created a case, and then this metal tab that at the moment is designed to be sort of part of the jacket, and there is a rechargeable battery. But we also created this magnetic USB connector, so you can very easily plug it and unplug it. So let's get to the interesting part. So we actually, part of this partnership with Keyway, we got a number of Keyways jacket, and we manufacture a number of these devices, and we are going to make them available to a number of people to develop applications based on our hardware platform, on the jacket, and on the Edge Impulse. So the idea is you have until November. So from November 9th, you can basically start sending us proposals. If you want to, so from now till November 9, you can send us the proposal of the kind of things you would like to build with this technology. You don't have to develop a whole project, just send us a message, and I will show the URL of the website where you need to send the information. So over here, you can apply and say, I would love to make a project, and you have to give us like a vague indication of the kind of project you would like to do. And then on November 22nd, we will let people know which project has been selected. And then we will start to ship a jacket with the device and everything included to the people that have been selected. So basically from November 30th, you can start work on the project, and you have to deliver the finished project by January 9th. So we give you a little bit of time. You can work during the Christmas holidays if you want to. And then on January 18, we will actually let people know which one of the which projects we thought were the best. And we will basically let you know, because there will be some surprises for the people that we selected, but we're not going to spoil too much right now. So the general idea is develop an interesting machine learning based application with this hardware on the jacket. You have the Edge Impulse tool integrated in Arduino. We are here to help as well. Sorry, I was looking because people started to ask a lot of very technical questions. And what's the clock? I think it's 64 megahertz. So this is not designed to be an insanely powerful computing device because it runs on a battery. So just to give you an idea, with just the algorithm that reads the air quality and flashes once a second, I was able to run the device for about 22 hours on the battery, which is, it allows you to go back home and plug it in and, charge it overnight and then have it ready for the next day. So it's a pretty decent. There's also a question about machine learning that someone, so if you want to answer that question as well, Jenny, if you click on the comments tab, there's a question that says, what is the size of the classification and applier? Okay.
Yeah, so the size of the classification and the anomaly detection model resulting from what you train in the Arduino machine learning tools, depending on the sensor that you've selected, the size of the resulting model will change, of course. But for this simple environmental sensor that's on board the Nicholas Sense, your model will result in around a 15K flash and a 1.7K of RAM usage, which is just enough to fit on the Nicholas Sense, and you shouldn't have any problems. Of course, as you change your sensor, for example, if you were to try to create like a Nicola Vision model, you wouldn't be able to flash it onto the Nicholas Sense, and there's not even a camera on board. So
Yeah, I guess if you start to work with things like this device has a 9-axis IMU, so if you start to extract the data from the motion sensor at a very high rate, it's clearly going to become more complicated.
yeah, exactly. But the ML tools will guide you through the process, depending on the hardware that you've selected. So it will make sure that it'll fit in the end. And then just to deploy, you select the Arduino library and you integrate it into your sketch just as you would any other Arduino project. So it's super easy, and yeah, you shouldn't hit any memory issues, at least for the types of sensors that are on board the Nicholas Sense.
Okay. Yeah, so I think I think something like this we wouldn't have done something like this if there were not the Edge Impulse tools. Let's put it this way. It would have been for an incredible small niche of people that have a lot of understanding of the kind of, the guts of the machine learning algorithm. But I think that, this collaboration allows us to open this competition to really a lot of different people who might not have a deep understanding of all the kind of inner details of machine learning algorithms, but with the tool they can experiment. Let's see. It is possible to use ML models with RTOS libraries to increase performance.
So I think this question, you can integrate the resulting Edge Impulse SDK library that is generated from the Arduino library that you have on the deployment tab from the Arduino ML tools. You can integrate that library just as you would any other Arduino ML library. So if you want to integrate RTOS type capabilities or other types of libraries that you can find in the Arduino IDE, for example, that's totally fine. Of course, like as you add more libraries, you might hit your memory limits, but you just have to give it a try. And if you encounter any issues specifically with the Edge Impulse resulting Arduino library, you can reach out to us on our forum at forum.edgeimpulse.com or email us at hello@edgeimpulse.com.
Thank you for that. And there's actually, because this person was mentioning RTOS, effectively, the Arduino code that you are using is running on an RTOS. So
Yeah.
the way we implemented Arduino on this particular processor is sitting on top of free RTOS. So the idea is that you already have an RTOS. So the library that Edge Impulse is generating, it's already running inside an RTOS. So if you know how to use emBedOS, and there are also articles on the Arduino website on how you can run, for example, some form of multitasking on the device itself. So there are different ways where you can optimize the behavior. And somebody say, is it possible to use the board in a final product? Well, basically, this is a final product because it's an enclosed case with a rechargeable battery, semi-waterproof case with with a hook. So we also designed the case in a way that the metal part that at the moment is connecting to the zip, it actually can be replaced with a different shape. So we already designed one that would allow you to mount the device on your wrist, one that will allow you to mount the device screw it on top of a different device. But the specifics of this competition is all about building something based on this device integrated in the jacket. So yeah, so to recap very quickly, you can send us the proposals. You should send us the proposal by November 9th, but we're not going to be super strict about it, but from November 22nd, we're going to select the people who will receive the jacket and the hardware. November 30th, so after the 22nd, we'll start to ship the kits to people. November 30th, you can start working, and then January 9th, finish the project, and then January 18th, we will let you know the one who won the competition, and in the meantime, in the next few weeks, we will let you know what kind of prizes we're going to give to people. Already, if you receive the hardware and the jacket, consider that you are already receiving something in the region of $300 of value. So it's already a nice gift, thanks to sort of the combined efforts of Keyway, Arduino, and Edge Impulse. So, okay, so these were the dates. We are also approaching the end of the streaming. We want to keep it short just to give an overview of the project. Yeah, look at that. It's the jacket. So the version that you're getting is the raincoat. So you're going to get this, it's like a thin, there's several versions of Keyways. This one is the thin one that kind of you wear on top of your clothes when it's raining, which is the classic application of Keyway. So before we end, I want to thank a number of people. So first of all, I want to thank Jenny for taking part in this thing and explaining the whole process and what, and also, can we say that you have a book coming? Can we start do early promotion on the book?
Yeah, sure. Yeah. Me and my colleague, Dan Satanaika, we are writing, or we have written a book called AI at the Edge. And one of the chapters, we use the Nicholas Sense for food quality assurance. So check it out. It's on Amazon, AI at the Edge.
I have received an early PDF because I am going to write a phrase about it.
Yeah, thank you so much for that.
Totally. I already, with Daniel, I had access also to, he wrote with Pete Warden the book about tinyML. So I had the pleasure to get early access to that as well. So, I think it's an essential book. It's very important. So I'm glad that this is coming out. And so thank you for all of this. And you should also, buy the book. To the audience, please buy the book.
Thanks.
And someone is asking if the competition is for individual or teams. You can work on it with a team. It's not a problem. You will get one device and one jacket. You cannot say my team is made of 10 people. Can I get 10 jackets? No, you're gonna get only one. But yes, you can work on it as a team. Yeah, absolutely. The objective is to create interesting application on this particular platform, which is the jacket plus the hardware plus Edge Impulse and Arduino. So that's the platform. Invent something really cool on it. If you want to work on it with the team, no problem. I wanted to add just a quick thanks before we go. So I wanted to actually start from Marco Boglione, who is the founder of Basic.net, which is the company that owns a bunch of fashion brands, including Keyway. So he graciously accepted this to do this, collaboration with us. Me and Marco know each other also because he has a big passion for vintage computers, which you can see here in the background. His collection is insanely amazing. Mine is very, very basic. But also Cecilia Botta, who helped in the project, Marco Costanzo from the marketing team at Keyway. So all these people helped out. And obviously, the people at Adam Benzion and Alessandro Grande from Edge Impulse that also kind of made this thing possible. And from our side, Anna Vigano and Lucrezia worked on the project. So I'm thank you for all these people to kind of coming together to make this happen. And thank you, Jenny. And we can say bye to the audience.
Yeah, thank you so much. And yeah, let us know if you have any questions and have a great time.
Thank you. Goodbye. Bye-bye.